me tell you now how to define these operations properly so that we actually know how to continue the sequence. Notice, by the way, that I've been putting this sub O to both addition and multiplication to remind you that that's not what you learned in high school. So like this is a weird, different beast. OK, so alpha plus beta is going to be intuitively so it's intuitively the result of starting with a sequence of type alpha and appending a sequence of type beta at the end. So notice how that's what's happened. So for example, take omega plus 1. What we did is we started with a sequence of type omega and then added an element at the end, so we get something of this shape. And what about omega plus omega? Well, we started with something of type omega, and we added something of type omega at the end. Does anyone have a suggestion about what a good definition for multiplication would be? Yes?
It'd basically be taking a sequence of type alpha and then appending sequences of type alpha, one for every element in a sequence of type beta.
Yes. Yes, 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 yes. So what you do is you treat beta as a template. And for each element of beta, you plug in an entire sequence of type alpha. So I'm going to write it down, and then we can do some examples. So intuitively, use a sequence of type beta as a template. So you plug in a sequence of type alpha at each position of your beta sequence. So for example, so we're looking at omega times 2. So you take a sequence of type 2, and for each position of these, you write down an entire sequence of type omega. So this is what you get. Yes?
About the multiplication, is it all right if multiplication only works one way? Because you've essentially lost a lot of what beta is.
Multiplication only works one way. That is absolutely right. And that's why I cheated a little bit. So when you said 2 omega, I slyly wrote down not 2 omega, but omega times 2. OK, so let's see what happens if instead of doing omega times 2, you try to do 2 times omega. The recipe says start with an omega sequence, and for each position of the omega sequence, write down a 2 sequence. So in other words, for this guy, we write these 2. And for that guy, we write those 2. And for that guy, those 2. And we keep going. And what we get is an omega sequence. So and that is why these are not the operations you learned about in school. What about addition? So is addition commutative? So let me remind you of the definition. Yes?
I mean, I don't think addition is commutative. Like, for example, on the board you wrote omega plus 1. And if we did a 1 plus omega instead, I feel like it would just become omega.
Yes. Yes, exactly. So the recipe for addition is, OK, so let's look at 1 plus omega. The recipe is you first write down a 1 sequence, and then to that you append at the end an omega sequence. So you just get an omega sequence. So 1 plus omega is omega. Yes?
I'm trying to think about multiples of omega sequences, and if you have like omega times omega, so you have like an infinite sequence of omega sequences, and that makes sense. But I'm not sure. At least we were talking about like the point of like how much infinity you can visualize in any way. So I'm trying to understand how omega times omega is different from omega times omega times omega, for instance.
Good. So let's do each of those, and then I'm going to acknowledge a limitation of my intuitive explanations. So first, omega times omega. So what you do is you start with an omega sequence, which you're going to treat as a template, and for each position in it, you're going to add an omega sequence. Omega many times. So we know what B stat is. And then for omega times omega times omega, what you do is you start with an omega sequence, and for each position here, you put in that whole beast. So in other words, what you get is so those are definitely different. Now, let me concede a limitation of my informal definitions. And I think that is a reason your question is a very good one. So at the end of the day, my intuitive definitions rely on the old way of thinking. They, in effect, rely on a geometrical way of thinking, because I talk about appending one sequence at the end of the other and using one as a template and adding stuff. So in order for it to be really true that you can use a new notation to go beyond the old ideas, you need to look at the formal definitions in the lecture notes. But it won't matter for these purposes. So what I want you guys to have is a rough idea of how addition and multiplication work, so that we can go forward and see like what happens after the baby cases we've been looking at. Now, a cool fact about multiplication and addition, which I won't prove, is that it does associate. So you do have this. And that's something just useful to keep in mind. So it means, for example, that you don't need to write parentheses for those cases.